So we already have an instance of MariaDB set up for you. In fact, you already have some credentials set up. So I'm going to skip around just a tiny bit because I do not want to potentially leak my username, my password, and a bunch of this other stuff that I just really don't want kind of floating out there on the internet. But the idea for here is that you're going to log into MariaDB by first SSHing into Silo. So let me open up a terminal, get kind of comfortable with where some of those kind of things are, move some things around, maybe make this a little bit bigger so it's real easy to see. So remember, we log into Silo with SSH. So in my case, that would be hazall silo.luddy.indiana.edu. Now, once I'm inside of Silo, I'm going to do a couple things, and I'm going to basically run this mysql command. So mysql-h. There's going to be something here like db.luddy.indiana.edu. There's going to be a username right here. There's going to be a password, which is something along these lines. And there's going to be a database, which something along these lines. Of course, mine is not really like this, but in just a moment, you will see what it looks like when I'm inside the database. Okay, so I'm inside the database. So right now, I will probably have a few tables inside of here. So if you watch me do like show tables, think of the show tables kind of being equivalent to like the idea where we could do an ls and a regular bash prompt. But instead of showing me files, it's going to show me all of the tables that I have. And I've been kind of working in here for a little bit. So you may not have anything when you show that, like maybe it's going to show you the empty set or something like that. But otherwise, let's jump into the database terminology. So most of these things are going to be pretty familiar to the things that were talked about originally in the relational model, where we have a table, which is a collection of related data organized into these rows and these columns. Each individual piece, such as this entire row right here, is called a record. Each of these columns inside of it is usually going to be called either a field or an attribute. And the sum total of all of these pieces together is the schema, where the schema is the logical structure or the design that defines how the data are organized and stored in the database. So think of this last term, the schema, kind of like a blueprint outlining all of the relations between the tables and the data within them. There's a lot of flowchart systems for organizing databases, which we kind of hinted at a little bit earlier with the entity relationship diagrams, but as long as you're kind of comfortable with this high-level idea where we have some relationships between tables and we have some columns defined in these individual tables, kind of like we had in CSV files, you probably have the gist of it. So the way that we will interact with these and the way we spend most of the time thinking about databases is through a little language called SQL, or structured query language. Without getting too much into the details, SQL is considered a declarative language compared to a procedural language like Python. So when we're writing Python, we have to spend a lot of time thinking about exactly like how we get data out. So we have to write a lot of things like for row in CSV do something. But once we're in a declarative language like SQL, we're not so much worried about like exactly how the operations work, as long as we're comfortable with the idea that we can type some commands and something happens. So asking questions is a way to think about SQL. You can ask a question such as, give me all the students at IU who are informatics majors, or give me all juniors at the Luddy School who are studying abroad in the spring semester. The way that this is done is through kind of that same representation. So if you remember, we talked about like this REPL, or this REPL implementation, where we are reading something, we are executing something, we print a result, and then we loop back up to the top step. SQL is doing something pretty much exactly like that. So we can use SQL to give commands such as insert, update, create, delete, alter. And this allows us to express concepts like, I want to update the record for an informatics student named Jackie Johnson to show that they have completed all course requirements. There's some conventions around this, but I've been doing this for a little while, and I cannot stand holding like the shift key while typing. It's just so much easier for me to write just lowercase stuff, but all of that's an option. There's a lot of ways that you can approach it, and SQL is pretty flexible between uppercase and lowercases. So I'm going to skip past a tiny bit where it's talking about like the create a table stuff. You can read this in a little bit more detail, but overall, the way to think about this is that you create a table that has a certain name, and that table contains a series of attributes with a specific data type and potentially some constraints on them. This thing right here at the bottom, this engine equals NODB, pretty much is just always going to be there. This maintains something called the, the referential integrity constraints. There's probably a bunch of typos inside of there, but for the most part, this is just something that you'll cover a lot more in more of a database course that actually talks about this kind of stuff. So I'm just going to get into a little bit of the details. You can kind of skim past that. Okay, there's a, oh, try that again. Where'd it go? Okay, so some common data types. You can have something like the varchar. You can have something like the char, tiny text, integers, decimals, etc. Date times, years, etc. A lot of different approaches. Constraints. Maybe you don't want things to be null. Maybe you want your primary keys to be auto-incrementing so that you don't have to manually edit these every time. Primary key, as we mentioned, this is the unique identifier that keeps track of everything. Okay, so I don't want to show just that just yet. So how would we write some SQL to create a books table which holds data about the following pieces? Okay, so how would I create like a unique ID? Okay, so let's try to think about that. And actually, let me just open up a new tab and maybe, let's see, do I have my i211? Yeah, I've got my starter right here. Let me open this up because I like having a text editor where I can sketch some notes out so that I'm not like worrying too much about like all these details behind the scenes. Okay, so maybe I have some notes and maybe I'll keep track of like some notes for, day 01.sql. Maybe make that a tiny bit bigger so you can follow along pretty easily. Let's see. Okay, so what are my goals here? So I want a unique ID number. So I want some kind of ID as an integer, and it's probably some kind of primary key. What's the next one? A title. Title up to 255 characters. What's the next thing? Okay, so the next thing is an author. And then the next thing is a published year. Then after that is a Goodreads rating. Rating, let's see, stored as a decimal number with 3 digits and 2 decimal places. Ooh, 3-digit, 2 decimal places. Okay, so let's kind of sketch out what that would look like. Okay, so the template, let's kind of jump back up to the template real quick, because we said that a create table looks something like this, where we would have a create and a table name. Okay, so starting from this template, create table, because I'm pedantic. So let's call this like the books table. Okay, so what are the attributes we need? Okay, well, let's drop that. Let's keep the engine equals NODB. So the first thing we need is an ID field. Okay, so let's take out that. This is going to be some kind of integer. We also want to say it's a primary key. I probably want to do something like auto_incremented in a moment, but that's okay. I'm not ready for that just yet. Okay, what's next? We need a title. It's up to 255 characters, so that's going to be that varchar thing, which maybe I'll also say varchar not null, because what does it mean for a book not to have a title? Author. Ooh, what did we say about authors? Let's see, author. Nope, don't look at the answer. Up to 100 characters. Okay, so author, let's also say that's a varchar up to 100 characters, not null. And maybe you're starting to notice that Alexander doesn't like null data and just kind of throws not null on everything. Okay, publish year. This one's tricky. So I think there is a year data type inside of SQL, but kind of a quirk of that is I think it's only good up to like the year 1901 and forward. So I'm just going to store this as another integer, not null. Goodreads rating. Okay, so 3 digits and 2 decimal places. Okay, so I think what this is referring to is that we want something like a score can be between 0 and 5.0. Specifically, if we're having 2 decimal places, then that would be something like 5.00. So the total number of digits is 3, and the number of digits following the decimal point is 2. This is kind of one of those things that drives me absolutely crazy about how SQL actually works, but that's because when we specify decimals, we think of it as 3 digits with 2 after the decimal point. Okay, so the last thing I'm going to do, I think the way to do this is auto_increment, but I don't know. I've done a lot of different database systems and it's slightly different in every single one. So I'm going to see if this actually works. So what happens if I select all this, put it on my clipboard, Control-Shift-V to paste it into my terminal? Oh, okay. Query, okay. 0 rows were effective. So let's see what happens if I describe the books table now. Okay, and that's a little bit hard to see, so let me try that again. Make it a little bit easier. Describe books. Yeah, okay, so we got the ID, the title, the author, the publish year, and the Goodreads rating. It looks like we had the primary key and the auto increment column created successfully. So I think I got this. Let's compare my solution now to the one that we were suggesting in the book. Okay, yeah. ID is an auto incrementing primary key, the title, the varchar, the publication year. Ooh, so we did stick with a year. There could be a couple reasons for that. I think I mentioned this a second ago, but the one downside of using the year like this is that I think the year data type is only good from like 1901 up to like the present or something like that. Actually, you know what? Why don't we actually just look this up right now? So MariaDB year data type. Let's read some documentation together. Yeah, year data type. Okay, so the year data type, technically you can specify it with 4. Okay, so, here it is. So let's zoom in on this. So in the 4-digit format, the allowable values are between 1901 to 2155, and you can store the year 0. Interesting. Okay, so yeah, their databases are weird. They tend to have a lot of quirks to them. But that's okay. Sometimes you have to just jump in the documentation to kind of understand how things work in the background. Okay, but nonetheless, looks like this is pretty much in agreement with all this other stuff. Maybe we had like this disagreement on like the not null versus null, but I think we're feeling pretty good about this. Okay, so let's keep going. So getting information about the database. I think we saw an example of this a second ago where you can say show tables, and that'll show you all of the things. I also use this DESC or describe command to say what are all the contents of the books. So if I were to do DESC books, semicolon after that. Okay, so describing books is just going to give me kind of like the description of everything inside of that. What happens next? Okay, so this is kind of what the interaction could look like. Okay, so modifying a table. I'm going to skip this section. I'm going to skip this section because we're not going to worry too much about modifying tables. You should be like vaguely aware that if we did like alter table title, maybe we change it from like a 255 varchar to like a, oh, I don't know, a 100 varchar. You can do that. For the most part though, we're going to try to ignore that in this course. Drop table, pretty useful. So that would be the opposite of create. So if we can create a table, so show tables, and maybe we want to get rid of that books table, we could just say drop table books. And then if we show tables again, we had books a second ago, but after we dropped the table, the result of that is that there is no longer a books inside of the books set. Okay, altering a table, like I said, I'm going to kind of I'm going to leave you kind of where that exists, but we're not going to touch this too much. Putting data into the data tables is going to be a little bit more important in practice. Okay, so insert into. Okay, so how does this work? Well, let's kind of bring back that day01 SQL. So let's bring our template into this. So what do I not need anymore? I don't need this. What does the template look like? Okay, so when we insert something, we have to specify a table name. Maybe we have to specify a set of attributes, and then we have to specify the values that we're going to put into them. Okay, so let's kind of fill in this template. What's a good example? So what's a good example? So maybe we would insert into, what is the table name? The table name is books. What are the attributes we're inserting? Okay, well, 1, 2, 3, 4. So maybe we could specify the title, the author, the publish underscore year, the Goodreads, if I can spell, the Goodreads underscore rating. Okay, so these are the things we're going to implement, or the things we're going to insert. What values are we going to insert? Okay, well, this is going to be a tuple. So I said 1, 2, 3, 4 things. So let's just kind of do 4 things inside of here for a moment. 1, 2, 3, 4. Okay, then now let's start filling in some data. So what is the title of the first book? Okay, well, let's do, I don't know, Designing Data Intensive Applications. I'm just kind of reading off my bookshelf right here to kind of guess some stuff. Okay, so this is by Martin Kleppman, two N's. What is the publish year? I think this was like a 2011 book or maybe 2012. I don't know. Maybe we'll change that in a little bit as soon as I find out. What is the rating? Okay, well, let's do 4.0, something like that. Okay, cool. So that's kind of the general sketch. Yep, there's no formatter for SQL. That's totally okay. Bad thing about SQL is it does tend to stretch over a couple lines, but that's totally fine. Okay, so we have an insert statement. So I bet when we run this code, it will update the books table and then put some information inside of it. So step one, let me just make sure I have a books table because I did drop it a second ago. Control-Shift-V, paste anyway. Actually, hold on. Probably update my shell at some point to make sure that I don't have to worry about that every time. But okay, we have a books table. Now what happens when we insert some data into it? Yes, paste anyway, I know. Okay, so let's zoom in on this. So after we called the insert, it said query, okay, one row affected, and it was done very quickly. So now if we select, wait a minute. Okay, hold on. So what have we covered so far? We've covered create or creating tables. We've covered putting or inserting data into it. What's the third step? Well, how do we get data out of a table? So for the most part, this is going to be the select query. So I'm just going to throw the vocabulary inside of there. And if we wanted to, the most common version of this, which we'll talk about for a moment, is if we want to get all data out of a table, that looks something like this. Select star from books. Okay, so basically select everything from which table? The books table. See what happens when we try that. Select star from books. It should respond. And again, it's a little bit hard to read, so I'll make that a little bit bigger. Try that again. Select star from books. Sure enough. Oh, and actually, notice it populated the ID automatically because we didn't have to specify the ID because it's automatically incremented. Yeah, okay. So Designing Data Intensive Applications by Martin Kleppman, published in 2011, and maybe our 4.0 was what we considered that. Okay, let's kind of see where we are. Okay, so we have some other suggestions. Yeah, so let's try inserting Fahrenheit 451. Sure, paste away. What happens if we implement a few of these? Ooh, and actually this one's really interesting because notice this one is implementing both Dune and it's implementing the dispossessed. Okay, so what happens when we do both of those? Oh, cool. We have 2 rows were affected. Now, if we were to say select star from books, now we have 4 pieces of information inside of our table. So while we're kind of talking about this, let's talk about some variations on the select statement. So the simplest one is, let's say that instead of selecting everything, what if we only wanted the title and the authors field? Well, you might kind of be able to imagine that instead of saying select everything, what if we just said select title, comma, author? And what if we just wanted the publish year? Or what if we just wanted to figure out, like, what are the ratings? Well, all of those correspond to just selecting specific columns out of our data. So let's try a few of those out. Let's see what happens if we select author from books. Or what if we select the author and the publish underscore year from books? So all of these kind of tell us different pieces of information. Like this query right here may give us some insight to when like certain people were publishing. Like in this case, it looks like most of these authors were kind of around like the mid of the 20th century. This gives us the set of all authors that we have access to, or we could just access like all of the data at once, which a lot of the time is kind of what you're doing when you're just kind of inspecting stuff. Okay, so we've covered the idea that you can add multiple things. You can insert data into the books. Insert the rest of the data in the books, either line by line. So when working with MariaDB on the command line, it can also be useful to type the SQL into a blank file, such as this books.sql or this day1.sql that I was kind of working on. Let's kind of keep going. Okay, so copying and pasting from the prompt. It's easy to make mistakes with commands this long. Yeah, so with a little pattern matching, we can make adding data pretty straightforward. Okay, so keep following along with me. I'm going to do this one real quick. So how would we do a few of these things? Okay, well, if we wanted to insert all of these things, let's just kind of copy this piece of information. So which values are we inserting? Okay, well, we insert into books. Which tuple are we doing? Okay, Hitchhiker's Guide to the Galaxy, and put that at the end. I think we have a missing comma somewhere. Oh, yeah, so this is a good example to look at. So do you see how there is this Hitchhiker's Guide to the Galaxy comma right here, which is conflicting with the, or excuse me, I said comma, this apostrophe right here, which is conflicting with this one right here. Okay, let's modify that a little bit. So instead of having the first one surrounded with single quotes, I'm going to modify that so that this one has a double quote around it. Let's see, otherwise I think that looks pretty good, so I'm going to be pretty happy with that. Put that around, add a comma at the very end. I think I have to add commas at the end of these lines, but that's okay. You know, let's see what happens if I don't add commas. Maybe that'll give us some hints as to whether like what it looks like when things break. Okay, so what happens if I try inserting all these inside of here? Ooh, okay. So now we have the dreaded problem. We get this error 1064. You have an error in your SQL syntax. Check the manual. If you ever want to see like bad error messages or like what not to do, oh man, you have an error in your SQL syntax, check the manual. That's not very helpful. Okay, but right syntax, it's near this thing, Ready Player One by Ernest Cline, 2011 4.23, and The Martian. Okay, so there's something slightly wrong between Ready Player One and The Martian. Let's see if we can translate that back into a problem. Okay, so Ready Player One and The Martian. This is actually one of those cases where I said a second ago, it's because we're missing the commas. Okay, so now let's see what happens if we go back and we try to execute this whole thing. Control-Shift-V, paste anyway. There we go. Query's okay, 4 records were affected, and now if we do select star from books, we should see that we have about 8 entries inside of it. Okay. So where are we at? I think we're getting pretty close to the idea. Okay, so updating, yeah, so update table. Let's just kind of pull out our example real quick. This is going to be a good example to maybe see if I can remember what the year is on that book. So we've covered the idea of how do we create tables, how do we insert data into the tables, how do we pull data out of them. Final question, how do we update data inside of the tables? Let's pull out that query or that template. So when we write an update statement, we want to have the idea of which table are we updating, what attribute are we modifying, what is the new value that we're setting it to, and then, conditions. Conditions. Okay, so here's the idea. There's certain rows that we want to affect, but we don't want to affect every single row. So here's that example from earlier. I was not confident about the year that Martin Kleppmann published Designing Data-Intensive Applications. So I've got a copy of it right next to me. Let's see if I can see what the year was. It is not 2012. It is actually 2017. Okay, so I don't want this value to be 2012. I want this thing to be replaced with the value 2017. Okay, so we have to figure out how do we represent the idea that we want to change exactly one row. Okay, well, we want to change the publish year. So publish year, the publish year should be now equal to 2017. So we want to update this row. How do we specify exactly one row? Think about that for just a moment. How do we specify exactly which row we want to update? Okay, well, we've been talking about the primary keys associated with each of them, so I think the easiest way would be to say that we want to update the row with ID 1 and set the publish year to 2017. Let's see what that looks like in code. So back over here, instead of, let's kind of compare those two pieces of information again. Okay, so we want to update the books table where we set, what do we want to set? We want to set the publish year to be equal to 2017. 2017. Let's remove some of these spaces just because I'm a little bit pedantic. Now, how do we know which one we want to update? Okay, so this is that condition. So where ID is equal to 1. Okay, so let's kind of look at this code real quick. Let's make a guess as to what's going to happen after we run this query. We update the books table. We have the ID equals 1, and then we want to change this first row where the ID is equal to 1, and specifically update the publish year to be equal to 2017. Take just a moment if you need to, try to kind of internalize how that might actually work. Now let's try running the code and seeing what happens. Control-Shift-V, paste anyway. Oh, so what's it say? It says query OK, 1 row was affected, 1 row was matched, 1 row was changed, 0 warnings were returned. That's a good sign. Now let's see what happens when we select, maybe select ID title publish underscore year from books where, if I can type, where ID is equal to 1. There we go. So as we said a moment ago, the publish year is now going to be 2017. Let's jump back over into the browser and see kind of where we're at. Okay, so there's a couple other suggestions, like maybe you could change a couple of the values. We covered select statements a little bit with the select from where syntax. And there's a lot of variations that you can do on these, such as selecting things like, you can actually do a little bit of pattern matching inside of this. You can be a little bit fancy and figure out like which years. Okay, so what if we select star from books? Okay, well now this is an idea of how do we get all of the books published after the year 2000. So select star from books where publish underscore year is greater than the year 2000. And sure enough, that will give us just the pieces of information. So I think this is really powerful. Like think back to that like turtles assignment we were originally working on, where we had to jump through like all of these hoops to even figure out like what was the mean value, or like what was the mean length of all these all the turtles in the data set. Think of like how much more convenient it would have been if you could have just said like, what is the average Goodreads rating of all that stuff? Anyway, I digress. Okay, so logical operators, a lot of other things you can do. Helpful for numeric data and delete. Okay, let's mention delete very briefly. So sure, delete books where title is equal to Ready Player One. Let's see what happens. So previously we had select star from books, and sure enough, it looks like Ready Player One is inside of there. If we are, Control-Shift-V, confirm that we're okay to delete that, to paste that. Query was okay, 1 row was affected. Now let's see what happens if we select star from books, make a quick prediction before I hit enter. What are you going to see in the database now that we've deleted this? Actually, here's a more interesting question. So do you see how it starts with 1 through 6, and then the Martian is currently number 8? Now that we've deleted Ready Player One, what do you expect? Do you think it's going to be 1 through 7, or do you think it's still going to be 1 through 6 followed by 8? Make a quick prediction about that. 1 through 6, 8, or 1 through 7? What do you think is going to be happening? Okay, let's find out. Sure enough, we did not magically reindex all of our information, and the Martian is still number 8. Maybe think a little bit behind the scenes and come up with your own explanation as to why that might be, because it could be really problematic if we were to change those ID numbers every time we actually ran a statement. Okay, so in summary, let's kind of do a quick overview of what we've done. So we now have the ability to connect to the relational database, which we talked about by first SSHing and then using our database credentials in order to log into the database. A good first step for a database is to understand the data we want to structure and make a plan for how those tables and the data within them will interact. But nonetheless, this skill is a focus in other courses. We talked about the create, we talked about the delete a tiny bit. I didn't really talk too much about the alter. It's better for other courses. And we talked about structured query languages as also a way to like update, insert, or etc. on all these things. So what we need to do next, and this is going to be the subject of the next few days, is we want to use this newfound skills to replace a lot of our things where we were previously loading from CSVs. Now we want to use this new skill to create an actual full stack application where we can pull data out of a database, update things inside of a database, and use this to power our recipe site instead of putting a lot of things together inside of these hacky CSV files. Okay, see you next time.